Hi guys, yeah, we're finally having a logarithm discussion. Okay, so let's get in. This is just a brief introduction to logarithm. So let's start by defining what is logarithm. We can simply define a logarithm as the inverse of exponentiation. Okay, you remember indices, right? And in indices, we can actually say that 2 to the power of 2 is 4. Okay, that's exponentiation. So logarithm is simply the inverse of it. And then we say it answers the question, to what power must a base number be raised to obtain a given value. So still using these indices for example, if 2 to the power of 2 is 4, we want to put this in log form, it would be log 2. 4 equals 2. So you can see the similarity, right? This just answered the question, to what power must a base be raised to obtain a given value. So what power can 2 be raised to obtain 4? So look at this. What power must 3 be raised to obtain 9? Is 2, right? Yes, because 3 to the power of 2 is equal to 9. What power must 4 be raised to get 16? Is 2. What power must 10 be raised to get 100? 2. So this is just a brief introduction to show you the definition of indices. Now we have something else to look at. We have types of logarithm. We have types of logarithm which we're going to do one by one, okay? So we have the common logarithm, which we call the base 10 logarithm. We have natural logarithm, we have binary logarithm, we have base p logarithm. So we're going to look at all these type of logarithm one by one in the next video. And don't forget to subscribe to the YouTube channel. So see you in the next video.